The universe has never known stillness. From the smallest vibration of a subatomic particle to the spiraling arms of galaxies a million light-years wide, motion is the thread woven through all of existence. Atoms tremble in ceaseless rhythm. Stars ignite and drift through the void. Galaxies pull against one another in colossal tides. Even the space between them, the silent fabric of the cosmos, stretches and expands, carrying entire realms away into darkness. This endless motion is more than a fact of physics. It is the heartbeat of reality itself. The cosmos resembles a river with no mouth, flowing outward without end. It is an orchestra that never concludes, a composition whose notes scatter and reform in infinite variations. Each movement, whether the swing of a pendulum on Earth or the collapse of a distant star, is part of a grand choreography, a dance in which every partner is forever changing, yet never allowed to rest. But motion raises a haunting question. If everything drifts, spins, and expands, then what lies ahead of it all? Galaxies recede at unfathomable speeds. Stars exhaust their fuel and fade, while the great web of matter stretches into colder silence. Does this relentless flow point toward a destination? Or is motion itself the destination, without promise of arrival? For centuries, humanity has looked to the night sky and wondered not only how things move, but where they are moving toward. From the wanderers tracked by ancient eyes to the redshift of galaxies discovered in the 20th century, the story of motion has been one of revelation and disquiet. It suggests a universe that is never fixed, never whole, but always becoming. And so, this story will follow motion itself. From the first discoveries that revealed Earth was not still, to the modern search for the fate of all things. From the restless trembling of matter at the quantum scale to the unstoppable drift of galaxies across the cosmic ocean. This journey begins not with answers, but with a mystery. If the universe never stops moving, where does it all lead? Long before instruments, long before equations, there were only eyes and the night sky. Ancient stargazers stood beneath its vastness and saw an order that seemed eternal. Most stars appeared fixed, locked in a crystalline sphere of permanence. But a few lights betrayed the illusion. They wandered, slowly, deliberately. They drifted across the heavens, breaking the pattern that held the rest. These were the planets, the wanderers, the first evidence that the sky was not an unchanging dome, but a stage of motion. Philosophers tried to explain this strangeness. To Aristotle, the earth was still the center of all existence. Objects sought their natural place, stones fell, fire rose, and celestial bodies circled endlessly in perfect spheres. Motion, in this vision, was purposeful, destined toward rest. It was an ordered cosmos where the heavens and the earth each obeyed separate laws. For centuries, this framework soothed the human mind. The stars seemed eternal, and the earth seemed steady, but shadows began to lengthen over certainty. In the Renaissance, Nicolaus Copernicus looked again at the wanderers and reimagined the stage. What if it was not the heavens that shifted, but Earth itself that moved? It was a thought both simple and radical, unsettling the belief that humanity occupied the still point of creation. Galileo Galilei would later raise a telescope and confirm what the naked eye could not. Moons circled Jupiter, the phases of Venus betrayed its orbit around the Sun, and motion was revealed to be everywhere. The Earth itself was a traveler. The cosmic order fractured, yet in the fragments lay a deeper truth. Isaac Newton gave motion its language, laws that united falling apples and circling planets under one principle. Gravity, invisible and universal, bound stars and stones alike. For the first time, motion was not an illusion, not a wandering anomaly, but the very fabric of reality. Celestial mechanics replaced celestial perfection. The heavens were not a realm of divine stillness, but a vast machine in perpetual motion. The telescope continued to sharpen humanity's vision. Nebulae once thought to be clouds of gas began to resolve into clusters of stars, hinting at depths beyond the Milky Way. The sky was no longer a fixed map, but a restless ocean of structures, drifting and colliding on scales the imagination could scarcely hold. Slowly, it became clear that even galaxies, once thought to be static islands of light, were rushing through the void in their own migrations. The origins of the discovery of motion were not sudden. They unfolded like dawn breaking across a darkened landscape, one light after another, revealing that the universe was never still, never centered, never secure. What began with the faint wandering of planets had expanded into a truth that reached across the cosmos. Existence itself was a story written in motion, and the stillness once imagined had vanished into myth. Yet even as these revelations unfolded, the recognition of motion was not merely scientific, it was deeply human. To suggest that Earth itself moved was to unsettle the very ground beneath people's feet, both literally and spiritually. The Copernican model displaced not just planets, but humanity from the throne of the cosmos. What once felt central became peripheral. The heavens no longer revolved around human life. Instead, human life became one brief spark in a universe of drifting worlds. Resistance was fierce. Religious authorities feared what such motion implied, that divine order could be questioned. Galileo, when he pointed his lens at the heavens, was not simply observing. He was challenging centuries of certainty. The moons of Jupiter became more than celestial companions. They were silent witnesses against the idea of perfect, unchanging skies. His findings forced an uncomfortable truth. Motion was not an exception, but the rule, written into every corner of the universe. Even with Galileo's defiance, the acceptance of a moving Earth was slow. To ordinary eyes, the ground felt solid, unmoving. It took Newton's genius to reveal why. His vision of gravity explained that motion need not be seen to be real. It could be inferred, measured, calculated. The orbits of planets, the fall of objects, the tides of the seas, all obeyed the same law. For the first time, motion was unified under a universal principle. The cosmos, from smallest pebble to grandest star, moved in harmony, bound by invisible threads of attraction. But motion proved to be more mysterious still. Telescopes of the 18th and 19th centuries pushed human vision deeper into space. William Herschel, mapping the stars, noticed that the sun itself was not fixed but carried along through the galaxy, dragging the Earth and all its planets with it. What once felt like the center was now revealed as a passenger, borne upon a cosmic current. The Milky Way itself was not motionless but turning, its stars in vast orbits around an unseen gravitational center. The scale of motion widened again when astronomers peered beyond the edges of the Milky Way. Faint smudges of light called nebulae began to split into two categories. Some were indeed clouds of gas, but others were entire galaxies, immense systems of stars drifting like islands through the night. The universe swelled in size, and with it, the realization that every luminous island was not fixed but carried along its own trajectory, sometimes colliding, sometimes fleeing from one another. Here, in the 19th and early 20th centuries, the origins of a greater mystery appeared. If even galaxies themselves were in motion, then what governed their paths? Was the cosmos static, balanced, eternal, or was it restless, driven by forces beyond comprehension? These questions, still fragile and uncertain, hinted at the grand revelations yet to come. the discovery that the universe was not only filled with motion, but that the very fabric of space was stretching, carrying galaxies apart in a ceaseless drift, in the long arc of human thought. The recognition of cosmic motion reshaped existence. What began as a simple observation, a planet wandering against the stars, had evolved into a truth that stripped away illusions of permanence. The Earth moved, the Sun moved, the galaxy moved, and perhaps the entire universe itself was not anchored but adrift, a vessel carried upon unseen tides. This was the foundation. The origins of the discovery of motion prepared the stage for the greatest upheaval of all, the recognition that nothing, not even the universe itself, would ever remain still by the dawn of the 20th century. The universe seemed vast, yet comfortably eternal. Stars filled the heavens in abundance, galaxies shimmered as distant lights, and many believed the cosmos was infinite, unchanging and balanced. Motion, though present everywhere, was thought to unfold within a static stage, a grand theatre whose backdrop remained unmoved across eternity. But hidden within the mathematics of Albert Einstein lay a truth that would fracture this vision forever. When Einstein completed his general theory of relativity in 1915, he had forged a new understanding of gravity, one in which space and time themselves were malleable, bending and curving under the weight of mass and energy. The equations did not merely describe motion, they described the stage upon which motion occurred. Yet when Einstein applied his formulas to the universe itself, the results unsettled him. His mathematics suggested not a cosmos at rest, but one that must expand or contract under the influence of gravity. The universe, his theory implied, could not be still. This was a possibility he could not accept. Like many of his contemporaries, Einstein believed the universe must be eternal and static. To preserve this vision, he introduced a delicate adjustment to his equations, the cosmological constant. It was a mathematical counterforce, designed to hold the universe in balance, to prevent collapse or runaway expansion. He later called it his greatest blunder, but at the time it restored the comfort of stillness. Motion was contained, balanced, domesticated. The universe remained eternal, yet nature did not bend to human preference. In the 1920s, a young astronomer named Edwin Hubble turned the eye of the 100-inch Hooker telescope at Mount Wilson toward the faint smudges of light in the sky. With meticulous care, he measured the spectra of galaxies, and in those faint lines he saw a shift. The light was stretched, shifted toward red, evidence that the galaxies were not fixed but racing away. The farther they were, the faster they fled. The universe was not static at all. It was expanding. This revelation landed like a thunderclap. For centuries, humanity had believed in eternal skies. Even Einstein's equations had been bent to preserve that illusion. But Hubble's discovery shattered it. The cosmos was not merely filled with motion. The cosmos itself was motion. Space was stretching, carrying galaxies apart, as if borne upon an unseen tide. The scientific community reeled. If the universe was expanding, it must have been smaller once. Could it have begun from a single moment, a singular birth? The notion was radical, unsettling. Some embraced the idea of a cosmic beginning, what would later become the Big Bang Theory, while others recoiled. For many, an eternal, steady-state cosmos still held more appeal. Perhaps, they argued, new matter was continuously created as galaxies drifted apart, filling the gaps to preserve a universe without origin, without end. These debates were not merely technical. They cut into the heart of human understanding. To accept an expanding universe was to accept impermanence on the grandest scale. The heavens were no longer eternal. They were evolving, changing, moving toward a fate that could not yet be seen. The comfort of cosmic stillness was gone. In its place stood a universe alive with restlessness, a universe whose very existence was a journey. For scientists of the early 20th century, the discovery was both thrilling and disorienting. It was a shift not only of equations, but of philosophy. If the universe itself could change, then certainty itself was fragile. The Earth had already been displaced from the center of creation. Now even the universe's permanence was stripped away. Everything moved, everything drifted, and the destination was unknown. This was the first reaction, or resistance, debate, and the quiet recognition that humanity had stepped into a new age of uncertainty. The cosmos was no longer a fixed cathedral, but a river of stars, flowing endlessly outward. And with this realization, a deeper mystery emerged. If the universe itself is in motion, where does it lead? The discovery of cosmic expansion had torn open a veil, but what lay behind it was still blurred, uncertain, waiting to be measured. The faint redshift in the light of galaxies had revealed that space itself was stretching. But how fast, and to what end, remained questions too immense to answer. Astronomers began to refine their instruments, bending prisms and mirrors toward the heavens, gathering the delicate fingerprints of starlight. Each line of the spectrum told a story: how fast a galaxy fled, how far the universe itself had unraveled. What once seemed infinite and static was now described as fabric, elastic, expanding, restless. In this dawning age of discovery, one voice rose early with bold clarity. Georges Lemaitre, a Belgian priest and physicist, looked at the same evidence and traced it back not to eternity but to a beginning. He spoke of a primeval atom, a single seed from which the cosmos had burst forth in motion. It was not a metaphor, but a physical hypothesis that the expanding universe must have once been condensed, small beyond comprehension, before erupting outward. His idea was unsettling, dismissed by some as theology in disguise, but it planted a seed that would one day grow into the Big Bang Theory. George Gamow, another visionary, carried the thread forward. If the universe began in fire, he reasoned, then its echo must remain. The early cosmos, impossibly hot and dense, should have cooled as it expanded, leaving behind a faint radiation permeating all of space. It was a bold prediction that the sky itself should still carry the whisper of its own birth. At the time, it was little more than speculation, a ghost written into mathematics, waiting for instruments sensitive enough to hear it. While these ideas gathered momentum, radio astronomy was emerging as a new sense for humanity. No longer bound to the narrow window of visible light, scientists began to tune their ears to the cosmos in longer, invisible wavelengths. Vast dishes turned skyward, catching the faint hum of the universe. It was through this listening that a new window opened. The discovery of the cosmic microwave background, though accidental, would later confirm Gamow's vision. The universe itself was filled with a low, ancient glow, the cooling embers of creation, stretched thin by billions of years of motion. Yet long before that confirmation, debates raged over what the evidence meant. Was the universe destined to expand forever, stars drifting into darkness until motion itself grew cold? Or would gravity, relentless and patient, one day pull it all back, collapsing galaxies into a final contraction, a big crunch mirroring the Big Bang? Some dared to hope for a perfect balance, a universe that expanded and slowed into equilibrium, neither collapsing nor dissipating, but holding itself steady like a vast cosmic breath held between inhalation and release. For the first time in human history, the fate of the universe was being written in equations, in data, in light captured from distant galaxies. Theories were no longer bound only to philosophy or myth, but to measurements. Redshifts, cosmic radiation, gravitational models, all became clues in the search to know where endless motion might lead. It was in these early investigations that a profound realization emerged. The destiny of all things was not hidden in distant prophecy, but in the laws of motion themselves. The story of the cosmos was being revealed as a story of movement, the stretching of space, the flight of galaxies, the trembling of particles, its beginning, its expansion, its possible end. All were inscribed in the mathematics of motion, a script still unfolding, a journey without pause. The questions grew sharper, the instruments clearer, but the mystery remained. The universe was not an eternal monument, still and complete. It was a process, a motion without precedent, and perhaps without end. But the universe, restless and mysterious, was not easily surrendered to consensus. For every equation pointing to a violent birth, there arose another voice calling for timelessness. Fred Hoyle, brilliant and unyielding, refused to accept a cosmos that had emerged from a singular moment of origin. To him, such an idea smacked of mysticism. He envisioned instead a universe eternally renewing itself, where new matter continuously appeared as galaxies drifted apart, filling the gaps so that the large-scale cosmos always looked the same, always balanced. He called it the steady-state model, infinite in time, unchanging in its grandeur, yet still in motion. The battle between these visions, a universe with a beginning and a universe without one, became one of the most profound intellectual struggles of the 20th century. Observatories across the world gathered data, mapping the sky with ever finer precision. Each redshifted spectrum, each faint smear of starlight on a photographic plate was scrutinized for clues. The heavens became not a backdrop of twinkling lights, but a record of time itself. As decades passed, nature began to offer hints that eternity might not hold. The discovery of quasars, dazzling beacons from the farthest reaches of space, revealed objects so distant and thus so ancient that their light carried stories from the youth of the universe. They shone with the brilliance of entire galaxies compressed into points, powered by ravenous black holes at their cores. Their sheer remoteness suggested a younger, evolving universe, not one that had looked the same forever. The weight of evidence leaned slowly toward change, toward dynamism, toward beginnings. And yet the opposition did not vanish easily. For many, the idea of a cosmic genesis carried an unease that science was not prepared to answer. What existed before? What set motion into being? Questions that seemed to trespass on the boundaries between physics and philosophy, between measurable fact and unknowable mystery. Meanwhile, predictions of a lingering cosmic afterglow remained like a prophecy waiting to be fulfilled. If the cosmos had indeed erupted from fire, then its light, stretched and cooled, must still bathe the universe invisibly. Astronomers searched for it, building sensitive instruments, though at first their efforts met silence. Then, in 1965, came the chance encounter. Arno Penzias and Robert Wilson, working with a radio antenna in New Jersey, were attempting to eliminate a persistent background noise. No matter what they did, no matter how they cleaned the instrument, even sweeping away nesting pigeons in the antenna's horn, the faint static remained. It was everywhere, uniform in every direction. What they had stumbled upon was not noise at all, but the oldest light in existence. The cosmic microwave background, the relic radiation from the newborn universe, had been discovered. It was the whisper of the Big Bang itself, an afterglow from when the cosmos was only 380,000 years old. Long before stars, long before galaxies, this was the moment when light first broke free, traveling across space for billions of years to reach their detector. With that single discovery, the balance tipped irrevocably. The steady-state model, elegant though it was, could not account for this universal glow. The Big Bang, once speculative, once controversial, now had its evidence written in the sky. The universe was not eternal in its form. It had a beginning, it was in motion, and its expansion was not an illusion but a fact. Yet the revelation, while triumphant, was not complete. The discovery of cosmic background radiation told of beginnings, but not of endings. The question still loomed: was this expansion destined to continue without limit, pulling galaxies apart into a cold, dark silence? Or would the weight of gravity, hidden in the mass of countless galaxies, an unseen dark matter, one day call the cosmos home, collapsing it back into fire? The more the universe revealed, the more it concealed. Each discovery opened a door, and behind it stood another mystery. Humanity had learned that cosmic fate was not written in myth, but in equations, in forces, in laws that governed every particle and every galaxy alike. Yet the end of motion, if there is one, remained hidden beyond the horizon of knowledge. The early investigations had shown the universe was not timeless, not still, not safe. It was alive with motion, born of it, defined by it, and perhaps destined to vanish within it. For the first time, science glimpsed not just the past of the cosmos, but the weight of its future. And with that realization came a sobering truth. To understand the universe was to confront the inevitability of change, and with it, the impermanence of all things. In the quiet hum of a New Jersey field, two engineers tuned their radio antenna, searching not for the cosmos but for clarity. Arno, Penzias, and Robert Wilson wanted silence, yet the universe refused them. No matter how they adjusted their instrument, no matter how meticulously they scrubbed away interference, a faint hiss remained. It was everywhere, uniform, unyielding. At first it was an annoyance, an error to be corrected. But in truth, it was the voice of creation itself. That persistent static was not noise, but light, stretched, cooled, and aged across nearly 14 billion years. It was the cosmic microwave background, the afterglow of a universe once ablaze with primordial fire. In 1965, humanity had stumbled upon its oldest memory. The discovery confirmed what theory had long whispered, that everything now in motion had once surged from a single searing beginning. The cosmos was not eternal stillness. It was a river that once erupted from a spring. Yet the discovery was not an end, but an invitation. The whisper of the background glow was faint, blurred, imperfect. To truly read its message, instruments had to leave Earth behind, rising above the noise of atmosphere and weather. And so began a succession of silent sentinels in orbit. In 1989, the COBE satellite unfurled its sensors to the sky. What it revealed was astonishing. The cosmic microwave background was not perfectly smooth. It carried ripples, tiny fluctuations in temperature no greater than 1 part in 100,000. These were not trivial imperfections. They were the seeds of structure, the faint fingerprints of quantum fluctuations magnified into galaxies. Out of these ancient wrinkles, gravity would one day weave stars, clusters, and a great cosmic web. A decade later, the WMAP mission sharpened the view, tracing the delicate variations across the heavens with tenfold precision. Then, in 2009, the Planck satellite pushed resolution to its limits, painting the most detailed portrait yet of the infant universe. From those maps, humanity measured its own cosmic birth certificate, an age of 13.8 billion years, a composition of matter seen and unseen, and a future still shrouded in uncertainty. But as the microwave background spoke of beginnings, other discoveries began to rewrite the narrative of motion in the present. Astronomers studying the rotation of galaxies found something deeply unsettling. The outer stars were circling far too quickly, moving as though held in the grasp of an invisible hand. By Newton's laws, they should have drifted away into intergalactic night, yet they remained bound. The explanation pointed to something unseen, a hidden mass outweighing the stars themselves. Dark matter, invisible, undetectable except through gravity, revealed itself not in sight, but in the way it sculpted motion. Galaxies, clusters, even the vast scaffolding of the cosmos were moving according to its silent command. With ever more powerful surveys, astronomers began to see the larger architecture. Galaxies were not scattered randomly, but arranged like beads along colossal threads. These filaments stretched for hundreds of millions of light years, intersecting at knots where galaxy clusters swarmed together. In between lay immense voids, cosmic deserts nearly empty of matter. Motion was no longer just the drift of stars or the expansion of galaxies. It was the streaming of entire universes into a vast, interconnected web, a structure so immense it dwarfed imagination. And yet, as staggering as these revelations were, the most shocking discovery was still to come. For much of the 20th century, scientists assumed the expansion of the universe must be slowing. Gravity, pulling on every galaxy, should gradually restrain the outward rush. But in the late 1990s, two teams studying distant type Ia supernova found the opposite. These stellar explosions, acting as cosmic model markers, revealed that galaxies were not merely receding, they were accelerating away. The universe was not slowing down. Its motion was speeding up. The culprit was something even stranger than dark matter, dark energy. A force woven into the fabric of space itself, pushing outward, countering gravity, and growing stronger as the universe expanded. With this revelation, the story of motion took a staggering turn. The cosmos was not merely drifting toward stillness or collapse. It was racing toward an unknown horizon, propelled by a force that defied comprehension. From the static of a forgotten antenna to the vast maps of cosmic filaments, from the invisible grip of dark matter to the repulsive push of dark energy, each breakthrough carved away certainty. The universe was revealed not as a quiet, fading stage, but as a restless and accelerating sea. Motion, once thought to be a rhythm tending toward silence, was instead a symphony building in tempo, rushing toward a future that even theory could not fully predict. The great question deepened: if everything moves, and if motion is not slowing but quickening, then what lies at the end of this unrelenting acceleration? The answer was no longer within reach of simple laws or steady imagination. It now lived in the shadow of forces that seemed to emerge from nothingness itself. The story of cosmic motion had reached a new chapter, where beginnings had been glimpsed, but the endings had grown darker, stranger, and infinitely more profound. The realization of cosmic acceleration did not arrive as a quiet fact, but as a thunderclap that reverberated across every corner of science. It forced cosmologists to redraw the future of the universe in a single stroke. For centuries, human imagination had framed the cosmos in familiar arcs, a universe born in fire, slowly cooling, perhaps destined to collapse back upon itself. Now, another possibility emerged, one stranger than collapse, more haunting than stasis. The universe might not only endure, but expand forever, faster and faster. Its galaxies swept away from one another until the night sky itself grew empty, dark energy. The invisible driver became both a revelation and an enigma. No laboratory on Earth had measured it. No instrument had captured it directly. Yet its fingerprints were written across the heavens. The fabric of space seemed to contain within it a pressure that defied gravity's pull. Unlike matter or radiation, it did not thin as the universe expanded. Instead, it remained constant, or perhaps even strengthened, as if the more space grew, the more this mysterious force emerged to fill it. In every distant supernova, in every subtle shift of cosmic microwave background patterns, the evidence was clear. The cosmos was propelled by something that lay beyond human comprehension. The implications of this motion reached into both the infinite and the intimate. Astronomers realized that galaxies not bound by local gravity would, over time, drift so far apart that their light would never again reach one another. Billions of years from now, observers in some distant corner of the cosmos would look upward and see only their own galaxy, isolated in darkness, unable to trace the evidence of expansion. The universe itself, in its ceaseless acceleration, would erase its own history, but the present held wonders as well. Motion was no longer a simple trajectory outward. It was layered, complex, and entangled. Galaxies spiraled around their hidden dark matter halos. Clusters fell into superclusters, drawn along vast filaments like rivers flowing into the sea. Yet all of these smaller dances unfolded upon a stage that itself was stretching beneath them. A fabric of space expanding faster with every heartbeat of time. The image was no longer of planets circling suns or stars drifting in galaxies, but of the entire cosmos caught in a surge, like leaves carried not just by the river, but by a river whose banks themselves were widening. The instruments that uncovered these truths became as much a part of the story as the discoveries themselves. Telescopes that once peered with mirrors and glass now extended their reach into invisible domains, capturing radio waves, X-rays, and the faint microwave glow of creation. Satellites like COBE, WMAP, and Planck were not merely machines. They were extensions of human vision, lifting perception beyond the atmosphere and into the silence of orbit. Their data was not a single image, but a symphony of numbers, woven into maps that revealed the architecture of existence. To gaze at those maps was to look not at distant galaxies, but at the very blueprint of motion itself, frozen in time yet alive in consequence. Each refinement of observation added a new layer of depth. Slight anisotropies in the cosmic microwave background hinted at the invisible scaffolding of dark matter. The clustering of galaxies revealed how gravity shaped the tapestry of the large-scale structure. Supernova lit up the accelerating void, guiding astronomers to measure the rate of expansion with ever greater precision. Piece by piece, a story emerged that was both elegant and disquieting. The universe was not a passive expanse, but an evolving entity driven by hidden forces that eluded direct grasp. For those who studied it, the revelations carried a weight both scientific and existential. The realization that dark energy constituted nearly 70% of the universe reshaped not only equations but perspective. Everything visible, stars, planets, life itself, was reduced to a small fraction of reality. The cosmos, in its restless surge, was not ruled by the seen, but by the unseen. Human existence unfolded in a thin sliver of matter, adrift on a sea of forces beyond imagination. And yet, the discoveries also offered a profound kind of beauty. The very fact that beings born of stardust could detect the faint hiss of the cosmic microwave background, or trace the acceleration of galaxies billions of light-years away, was itself a testament to motion. The particles in human blood, the photons striking the retina, the neurons firing in contemplation, all were expressions of the same cosmic momentum. In this way, motion was not only a property of the universe, but a bridge of connection between the infinite and the intimate, between galaxies and thought. As the 20th century closed and the 21st opened, the narrative of cosmic motion was no longer one of speculation. It was a measured truth, sharpened by data, confirmed by observation, and yet still cloaked in mystery. Motion had revealed itself not as a gentle river tending toward rest, but as an accelerating tide sweeping all things toward horizons unseen. What lay beyond those horizons could not yet be told. But one truth had become unshakable. The universe was not only in motion, it was in motion toward something humanity could not yet name. The story of motion should have grown simpler once its driver was found. But with the discovery of dark energy, the cosmos became more elusive than ever. This unseen force was unlike anything humanity had known. It did not pull like gravity, nor push like wind. It resided in the very structure of space, a quiet insistence that every corner of the universe must drift away from every other. It was the breath of the void itself, stretching the fabric of existence faster with each passing age. This acceleration revealed a chilling truth. The universe was not only vast, but parts of it were slipping away forever. Galaxies already distant enough would, in time, recede beyond a boundary no signal could cross. This boundary, the cosmic horizon, was not a wall in space, but a limit in time, a line past which the speed of expansion outran even light itself. Everything beyond it became unreachable, untouchable, not because it no longer existed, but because the expanding fabric of space itself carried it away faster than any message, any photon, could return. It was as if the cosmos were a great ocean, and humanity lived upon a solitary raft. Near the raft, other vessels still floated, visible, approachable, but at the farthest edges, ships drifted outward, carried by currents stronger than any oar, until their sails vanished below an unreachable horizon. The universe was still full, yet it was also emptying before human eyes. Here lay a paradox that unsettled the foundations of science. Gravity, the ancient force that once bound planets to suns and galaxies to clusters, should have slowed the outward surge. Instead, the universe was accelerating, as though gravity had been overruled by a deeper law. What was the nature of this energy? Was it truly a constant of space, as Einstein once imagined and then abandoned? Or was it a new field, an evolving force, waxing stronger as the universe expanded, destined to dominate all motion until no structure remained intact? The more precisely instruments mapped the heavens, the more unsettling the story became. The cosmic microwave background, once thought to be a perfect snapshot of randomness, contained hints of something stranger. Subtle alignments stretched across the sky, patterns so improbable that some called them the axis of evil, too many. These anomalies were mere statistical quirks, shadows of instruments or noise in the data. But to others, they suggested that the universe's expansion carried an imprint, a preferred direction, a hidden symmetry not yet understood. If true, it would mean motion was not wholly random, not aimless scattering, but perhaps guided by rules written deeper than the known laws of physics. In this light, motion itself began to feel more fundamental than the matter it carried. Atoms, stars, and galaxies seemed to be passengers, their destinies dictated by currents far larger than themselves. Dark matter pulled the galaxies into vast networks, but dark energy unspooled the fabric beneath their feet. What appeared solid, the constellations, the familiar arc of the Milky Way, was a fleeting arrangement, a temporary shape in an expanding tide. Speculation pressed further still. If the acceleration continued unimpeded, distant galaxies would vanish from view. Then even the nearest clusters, until only the Milky Way and its companions remained, an island adrift in silence. Time would stretch onward, yet the universe would grow lonelier, emptier, its great chorus of motion muted into solitude. In the farthest reaches of future imagination, if dark energy were to grow stronger still, even atoms might be torn apart. Space itself, unraveling in a catastrophic acceleration, a fate some called the Big Rip, but the truth, for now, remained unresolved. The acceleration could be constant, it could evolve, it could even fade. Each scenario told a different story of destiny, yet in all of them, one truth held: motion was not slowing toward rest, as once imagined, but accelerating into horizons unseen. The cosmos was not gliding toward a destination, it was rushing away from the possibility of one. The deeper science probed, the more it revealed not certainty but questions. Why should the universe be governed by a force so exquisitely small yet so profoundly dominant? Why should it have emerged only in this age, billions of years after the Big Bang, just as galaxies reached maturity? Was this timing coincidence, or a clue to a larger principle not yet glimpsed? Dark energy, invisible and intangible, had deepened the mystery rather than solved it. It transformed the simple idea of expansion into a profound enigma, motion without origin, without destination. A universe where the journey itself might be the only truth. The search for clarity grew more urgent as the mystery deepened. To understand dark energy was not merely to explain a force. It was to grasp the future of everything. Astronomers turned the largest telescopes toward the faintest galaxies, while physicists built theories that stretched beyond the borders of established law. Yet each discovery seemed to widen the chasm of uncertainty rather than close it. Large-scale surveys such as the Sloan Digital Sky survey began charting the distribution of galaxies across billions of light-years, measuring not just their position but their subtle drift. Patterns in this drift hinted at a strange balance between attraction and repulsion, galaxies drawn into clusters by gravity, yet simultaneously carried apart by the swelling tide of expansion. It was as though the universe were caught in a perpetual tug-of-war between forces both known and unknown, visible matter bound to invisible matter, all suspended within a fabric that itself refused to remain still. The paradox grew sharper as scientists realized how delicately tuned the balance must be. If dark energy was slightly weaker, gravity would have slowed expansion long ago, perhaps pulling the universe back into collapse. If it was slightly stronger, structures might never have formed at all. No galaxies, no stars, no worlds, no observers to wonder at the mystery. The existence of cosmic motion as it is seemed balanced on a razor's edge, as though the laws of nature had conspired to allow just enough time for complexity to arise before, sweeping it all outward into unknowable distance. Within this fine-tuned balance, some began to glimpse echoes of deeper questions. Was dark energy a temporary phase, a ripple in the evolution of space itself, destined to fade in cosmic time? Or was it an immutable property of the vacuum, a constant embedded in the equations of reality? The difference was not academic. It was existential. A fading dark energy could mean a universe that slows, perhaps even cycles. A constant one meant eternal acceleration, isolation, and silence. And an evolving, strengthening form could herald an end more violent than any collapse, a tearing of galaxies, stars, even atoms, as the very fabric of space unraveled. But beyond these calculations lay a quieter truth. The more the universe expanded, the more unreachable it became. Already, billions of galaxies had slipped beyond the cosmic horizon, their light eternally lost to human eyes. What remains visible is but a shrinking fraction of what truly exists. Each passing moment carries more of reality beyond reach, and with it, more of history beyond retrieval. The sky, once thought eternal in its constellations, is a fleeting projection, a temporary view of neighbors who are already departing. Even the cosmic microwave background, that ancient glow of origin, whispers of this fate. Its photons, stretched to microwaves, are faint relics from the earliest seconds. As the universe continues its acceleration, they too will fade, stretched beyond detection until even memory itself is erased from the heavens. What remains is motion without witness, expansion without record, a universe whose very act of moving forward erases its own past. The alignment anomalies in the background radiation only deepened the enigma. If they are real, they suggest that motion may not be fully random, that some subtle architecture underlies even the apparent chaos. Yet no explanation has unified the data. The universe offers hints of design but denies certainty, as though guarding its deepest truths behind a veil that expands faster than inquiry itself. In this silence, motion reveals itself not merely as a property of the cosmos, but as its essence. Matter, light, and energy may all be passengers. It is motion that is fundamental, the restless unfolding of space and time, the ceaseless drift that allows galaxies to form, stars to burn, and minds to awaken. To ask where all of this is going is to ask whether motion itself has an end, or whether it is the one eternal rhythm, persisting even as forms dissolve. The mystery of dark energy did not solve the question of motion. It transformed it. No longer was the universe a predictable clockwork winding toward rest. It was a surge, an acceleration into horizons forever receding. And within that revelation, the haunting thought remained. Perhaps the destination of motion is not a place at all, but the act of moving itself, endless, a dance without end. The pursuit of motion's ultimate truth has carried humanity to the very edge of science. Instruments once thought impossible now turn their gaze into realms where even imagination struggles to follow. The James Webb Space Telescope, suspended in the cold silence beyond the moon's orbit, peers deeper into time than any eye before it. Its mirrors unfold like the petals of a golden flower, catching the faintest whispers of light born billions of years ago. Each photon it records is not only an image of a distant galaxy, but a messenger of motion, proof that the universe has never ceased its journey forward. Beyond telescopes, vast machines buried beneath the earth hurl particles together at nearly the speed of light. Within these collisions, physicists search for the imprint of the vacuum itself, for the invisible fields that may drive cosmic acceleration. Could dark energy be woven into the very fabric of quantum space, a pressure born from fluctuations so subtle that they ripple through the whole of reality? The experiments are precise, yet the answers remain elusive. In their absence, speculation grows. Perhaps the vacuum is not empty at all, but a restless sea whose tides propel the expansion of the universe. Gravitational wave observatories add another voice to the chorus of discovery. Detectors on Earth, sensitive enough to measure distortions smaller than a proton's width, have begun to capture the shudder of spacetime itself. When black holes collide, the cosmos trembles, sending ripples across billions of light-years. These waves carry no light, no matter, no particles, only motion itself, etched directly into the geometry of existence. To listen to them is to hear the universe speak in its native language, a reminder that motion is not merely what happens within space, but the shifting of space itself. Yet as powerful as these instruments are, they confront a wall. The observable universe, the sphere defined by the speed of light and the age of time, is a horizon that cannot be crossed. Beyond it may lie an infinite expanse, perhaps even other universes, with laws unlike our own. Some theories suggest that what we see is a single bubble, one region of motion amid a vast multiverse sea, where expansion may differ from one domain to another. If true, then the question, where is it all going, expands into something vast. Perhaps there is no single destination, but countless journeys unfolding simultaneously, unreachable to one another, yet bound by a shared origin in the quantum vacuum. At the heart of this vision lie fluctuations, so minute they defy comprehension. Quantum mechanics teaches that even in absolute emptiness, uncertainty reigns. Particles flicker into existence and vanish, like sparks in an invisible storm. These ephemeral disturbances, magnified by inflation in the earliest moments of time, seeded the galaxies themselves. From such microscopic restlessness arose the vast cosmic web, filaments spanning billions of light years, rivers of galaxies flowing through space. In this sense, the greatest motions of the universe trace their ancestry to the tiniest tremors of the void. But the deeper science ventures, the more unsettling the horizon of understanding becomes. Instruments grow sharper, theories more intricate, yet the mystery of motion remains untouched at its core. Dark energy continues to resist definition. The vacuum remains ambiguous, neither empty nor full, neither nothing nor something. Observers stand before a vast ocean, watching its waves, measuring its tides, yet unable to glimpse the shore. This is the philosophical crisis at the edge of science. Motion, the most evident of all realities, may be the most unknowable. Galaxies flee into silence, waves ripple through space-time, particles dissolve into probability, and still the essence of the journey lies beyond grasp. Perhaps the universe does not hide its secrets out of cruelty, but because its very foundation is not a thing to be known, but a rhythm to be witnessed, an endless unfolding, carrying all of creation with it, into horizons that forever recede. Yet even at this frontier, science knows it stands only at the beginning. The James Webb Telescope's golden mirrors may have opened a window onto the first galaxies, but new visions are already being prepared. Plans for the next generation, the Nancy Grace Roman Telescope, the extremely large telescope rising in the Atacama Desert, and even space-based interferometers, all aim to sharpen the view of cosmic acceleration itself. These machines are not built to gaze at beauty alone. They are built to measure motion with a precision so fine that the invisible might be revealed. The drifting of galaxies, the bending of light by unseen masses, the faint fingerprints of dark energy on the growth of cosmic structure. But telescopes alone cannot carry the weight of this mystery. Beneath mountains and within vast underground caverns, particle physicists push deeper into the fabric of reality. Their search is for what cannot be seen: ixions, sterile neutrinos, particles that may reveal the scaffolding of dark matter, or the whispers of fields that drive cosmic expansion. Each collision within the Large Hadron Collider is a miniature reenactment of the early universe, a flash of energy that might betray the forces responsible for motion on the largest scales. Still, silence prevails. The universe does not surrender its secrets easily. Meanwhile, gravitational wave astronomy begins to stretch beyond its infancy. Soon, with instruments like LISA, an observatory planned for space itself, scientists hope to hear not just the cataclysmic roars of merging black holes, but the gentle background hum, the cosmic symphony of space-time ripples, left over from the first instance after the Big Bang. To detect such a signal would be to listen to the heartbeat of creation, the very vibration of motion at the moment time began. And yet, with every step forward, the questions grow stranger. If the universe is accelerating, if more and more of it slips beyond the horizon each day, then science faces an ultimate limit. There may come a time when no galaxy beyond the local group is visible, when the night sky is empty save for our own stars, when the memory of cosmic expansion can no longer be observed at all. If science depends on evidence, what happens when evidence itself fades beyond reach? Humanity may be living in a privileged age, one of the rare cosmic epochs when the universe is still wide open to observation, before the shutters of acceleration close forever. The idea that everything is moving toward silence unsettles even the most disciplined minds. Some turn to the multiverse, imagining that our accelerating cosmos is but one bubble among countless others, each governed by its own rhythm of motion. Others look still deeper, to the quantum foam beneath space-time, where uncertainty reigns. Here, the very act of measuring motion dissolves into probabilities. Perhaps reality itself is not built of matter or energy, but of fluctuations, restless, unending, eternal. It is at this edge where science begins to mirror philosophy. The universe can be measured, mapped, modeled, but its essence, the meaning of motion, the reason for its unceasing expansion, may remain beyond any equation. What if motion itself is the one irreducible truth? What if the cosmos is not moving toward a destination at all, but simply expressing its nature, to flow, to expand, to become? At the extreme edge of science, the questions turn back upon themselves. Telescopes seek the past, accelerators probe the invisible, detectors listen for space-time itself, and still the answers slip away like light beyond the horizon. Perhaps this is the final revelation, that the shore will never be reached, that motion is the ocean, and that all of creation is adrift within it, carried endlessly forward by a tide without end. As humanity peers further into the depths of the expanding universe, one question lingers like a shadow at the edge of every discovery. What is the ultimate fate of motion itself? For while galaxies race apart, while the cosmic web stretches toward horizons unseen, all this activity must lead somewhere. The universe, vast and restless, carries within its motions the seeds of its own destiny. The most sobering vision is the heat death of the cosmos, sometimes called the Big Freeze. In this scenario, the universe expands without end, galaxies fleeing farther until their light can no longer reach one another. Stars burn out, one by one, their fuel exhausted. Black holes evaporate over incomprehensible spans of time, releasing their mass in fading whispers of radiation. The cosmic temperature falls ever closer to absolute zero. Motion continues, but it becomes thin, diluted, devoid of structure. In this endless twilight, time itself stretches toward infinity, yet nothing remains to mark its passage. The cosmos becomes a silent ocean, still expanding, but stripped of the fire that once gave it brilliance. Opposite to this fate lies a more violent imagining, the Big Crunch. Here, gravity does not surrender forever. Instead, at some unknown tipping point, expansion halts. Galaxies cease their outward flight, the fabric of space reverses, and all creation begins to fall back upon itself. Over billions of years, galaxies collide, stars spiral together, matter compresses into denser and hotter forms. At the final moment, every atom, every photon, every ripple of space-time converges into a singularity, a mirror of the beginning, a return to the primordial fire. Some theories extend this vision further, suggesting that such a collapse could ignite a new universe, a cosmic rebirth from the ashes of the old. More unsettling still is the prospect of the Big Rip. In this vision, dark energy does not remain constant. Instead, it grows stronger with time, forcing expansion to accelerate beyond all bounds. First galaxies dissolve, torn from one another by space itself. Then stars are unbound from galaxies, planets from stars, atoms from their nuclei. Even the fabric of space-time would stretch until it shatters. The universe does not end in silence, nor in collapse, but in dismemberment, a cosmos ripped apart by the very force that once carried it forward. Yet there are those who imagine the universe as a rhythm without end, cyclic cosmology, where expansion and contraction follow one another like the beating of an infinite heart. In these models, the universe is reborn again and again. Each cycle erases the past, but each new expansion arises from the collapse before it. If true, motion itself may be eternal, not toward a destination, not towards stillness, but repeating in endless cadence, as if the cosmos itself breathes. Among these visions, one has gained the strongest foothold in the scientific community. Observations suggest that expansion will not reverse, nor will dark energy tear the cosmos apart too soon. Instead, the universe appears destined for a slow, inexorable freeze. Heat death is not spectacular. It offers no grand collapse, no violent finale. Instead, it is a fading of motion, a thinning of energy until nothing remains to fuel change. The cosmos would not die in fire, but in the quiet erosion of activity, until only darkness endures. And yet, even this consensus is fragile, dependent on assumptions about dark energy that remain unproven. The truth is that no final certainty exists. The ultimate fate of the universe is still unwritten. Every telescope, every particle accelerator, every new observation continues to refine, to shift, to reshape the possibilities. What remains clear is that motion, whether it ends in silence, collapse, rupture, or rebirth, will decide the story. The cosmos was born in motion, and it will die or renew by that same law. In this sense, motion is not merely a feature of the universe. It is its essence, from the smallest vibration of a particle to the grand sweep of galaxies. All of existence is carried forward by the same tide, toward an end that is both inevitable and unknowable. If the heat death of the universe is indeed its destiny, then entropy becomes the silent architect of fate. Entropy, the measure of disorder, ensures that energy, once released, cannot be fully reclaimed. Stars burn hydrogen into helium, helium into heavier elements, releasing light and heat into the void. Black holes devour matter, but even they cannot escape this law, bleeding out their mass through Hawking radiation until nothing remains. The second law of thermodynamics points in only one direction, toward equilibrium, a state in which differences of energy are erased, and with them the possibility of work, of change, of motion with meaning. In this vision, the cosmos does not end in catastrophe, but in dilution. Imagine galaxies drifting apart until no light can cross the gulf between them. Imagine the night sky, now alive with countless stars, becoming empty as the farthest suns slip below the horizon of visibility. Eventually, even the closest stars exhaust their fuel, leaving behind faint embers, white dwarfs, neutron stars, and black holes. Over unimaginable spans of time, even these remnants decay. The universe, once ablaze with light and structure, becomes an ocean of thin radiation, stretched so far and thin that it no longer has the power to sculpt new worlds. The heat death is less a finale than an endless fading, the music of creation reduced to silence, stretched out over eternity. But while entropy offers inevitability, observations leave room for alternate endings. The Big Crunch, though less favored, still whispers as a possible conclusion. For if dark energy's behavior changes, if it weakens with time rather than strengthening, gravity may yet reclaim the upper hand. Galaxies now flying apart would one day slow, pause, and begin the long fall inward. The cosmic film would reverse, not instantly, but gradually, as every cluster of stars felt the tug toward the center. Temperatures would rise, radiation would intensify, matter itself would compress beyond recognition. If the universe began with a fiery singularity, perhaps it will end in one too. The symmetry of beginning and end has long captivated thinkers, a universe that returns to its origin, that begins and ends with the same flash of incomprehensible density. In such symmetry there is elegance, a circle rather than a line. The Big Rip, by contrast, embodies asymmetry, a finale driven not by balance but by excess. It rests on a frightening possibility, that dark energy's density is not constant but grows with time. If this is true, then acceleration does not simply continue but accelerates toward infinity. First, clusters of galaxies are torn apart. Later, individual galaxies are shredded, stars stripped from their orbits. Planets drift into darkness, molecules unravel, atoms disintegrate, and finally space-time itself is torn open. The rip is the ultimate dismemberment, an ending in which motion itself becomes too violent to sustain form, where the big freeze is quiet, and the big crunch is violent but whole. The rip is dissolution, everything scattered, nothing left intact. Between these extreme visions lies the rhythm of cyclic cosmologies, which propose that the universe may breathe in expansions and contractions without end. Each cycle erases the memory of the last, yet sustains motion eternally. Expansion gives way to contraction, contraction to rebirth. The current universe, in this framework, would be only one act in an endless performance, one crest in an infinite wave. Though modern data leans away from such models, they remain deeply alluring, for they give motion permanence. In cyclic universes, there is no final silence, no ultimate stillness, only recurrence, like a heartbeat echoing across eternity. Among scientists, the weight of evidence falls on heat death as the most probable fate. The discovery of accelerating expansion suggests that gravity cannot reverse the tide, and dark energy appears constant rather than runaway. But even within this consensus, humility lingers. Measurements of dark energy are still young, their precision limited by the reach of telescopes and the subtlety of cosmic signals. The possibility remains that the laws of motion, when stretched to the horizon of time, could reveal behaviors unknown today. The future of the universe is not yet locked in a ledger. It is written in equations still being tested, in forces still being measured, in mysteries still unresolved. What unites all these visions, freeze, crunch, rip, or cycle, is that motion defines them. Whether motion thins into stillness, collapses into singularity, tears itself apart, or repeats endlessly, it is motion that carries creation to its conclusion. The universe will not simply fade. It will journey toward one of these fates by moving, always moving, until the end is reached. In that sense, the ultimate destiny is not an escape from motion, but its culmination, the last step of a journey that began in fire. Beyond the boundaries of mainstream consensus lies a realm of speculation, visions, that stretched the imagination as far as telescopes stretched the eye. Here, the fate of cosmic motion is not confined to collapse, silence, or rupture, but to possibilities that seem to touch the fabric of reality itself. These theories remain on the margins of certainty, yet they persist because the universe, vast and enigmatic, often reveals truths stranger than the imagination dared to expect. One such vision is that of the multiverse. In this picture, the universe is not the totality of existence, but a single bubble in an infinite cosmic sea. Each bubble, born from quantum fluctuations or higher dimensional processes, expands like ours, carrying its own laws of physics, its own story of motion, its own destiny. In this framework, the expansion of our universe is not unique, but part of a grander flow where universes endlessly appear, drift, and vanish. If true, motion may not end with the fading of stars, for beyond our horizon lies an endless choreography of worlds, each moving to rhythms we cannot hear. The ultimate destination of our cosmos would then be less important than its role within an eternal foam of creation. Another bold speculation is Roger Penrose's conformal cyclic cosmology. In this model, the distant heat death of the universe is not a finale but a beginning. As entropy drains and particles lose mass, time itself stretches until the distinctions of size and scale disappear. In this smooth, featureless state, a new Big Bang can ignite, not from collapse, but from the very stillness of the old. The ashes of one universe become the fire of the next. In this way, motion never ceases, but transforms, flowing seamlessly from eon to eon, a cosmic river looping endlessly back upon itself. What appears to us as the end is merely a door to another chapter, written in a language too vast for mortal time. Others have turned their gaze inward, questioning not the universe, but the nature of reality itself. In the simulation hypothesis, the motion of galaxies, stars, and atoms may not be fundamental at all. Instead, what is observed could be the output of an unimaginably advanced computation, running on a substrate beyond physical reality. Just as the pixels of a screen conjure landscapes and characters, the universe may be a projection of code, its laws of physics a set of programmed rules. In such a vision, motion is not the heartbeat of the cosmos, but the illusion of change created by hidden algorithms. The stars, the galaxies, even the flow of time may be less than ultimate shadows cast by an unseen architect. The mainstream theories point to endings, freeze, crunch, rip, or cycle, but these speculative visions point to continuations, to transformations, to revelations. They remind us that motion may not lead to nothingness, but to horizons beyond imagination. Perhaps the universe is not only moving through space, perhaps it is moving toward meaning, toward truths concealed in the silence beyond the stars, and in this possibility lies both awe and humility. For even if the ultimate fate of the cosmos remains unknowable, the act of asking, of daring to imagine, places humanity within that grand motion, a fragile species on a small planet, swept along by cosmic currents, yet still reaching for the shore that may not exist. The multiverse hypothesis, though unproven, gathers weight from the mathematics of inflationary cosmology. In its earliest moments, the universe is thought to have expanded at an inconceivable rate, a fraction of a second stretching the quantum foam into the vast expanse of today's cosmos. Yet the mathematics suggests inflation may not end everywhere at once. Some regions stop inflating, forming bubble universes like ours, while others continue to swell, birthing more bubbles endlessly. This eternal inflation paints a picture where motion is not confined to one expanding universe, but to an infinite frontier where creation itself never ceases. In such a vision, the death of our cosmos would not mark the extinguishing of motion, but a passing ripple in an eternal sea of beginnings. Penrose's conformal cyclic cosmology attempts to glimpse this eternal flow by searching for echoes of past eons in the cosmic microwave. Background: According to his proposal, faint circular patterns in the afterglow of the Big Bang may be scars left by supermassive black holes from a previous universe, evaporating into the next. Though the evidence remains contested, the mere suggestion that traces of another cosmic epoch may already be imprinted across our sky brings unsettling wonder. If true, the light we see at night may not only belong to our own universe, but may carry whispers of universes long dissolved into silence. The holographic principle, born from the study of black holes, also reshapes the meaning of motion. When physicists calculated how information might be preserved as black holes evaporate, they found a paradox. The amount of information within a black hole appeared to be proportional not to its volume, but to the surface area of its event horizon. This radical insight led to the suggestion that all of reality could follow the same rule. What we perceive as three-dimensional motion may be like the movement of shadows, a projection of deeper processes inscribed on a cosmic boundary. Galaxies drifting apart, stars orbiting, atoms vibrating, all may be flickers of a deeper language written in invisible script, emergent. Space-time builds on this idea by weaving motion directly from entanglement. In the quantum world, particles separated by vast distances remain mysteriously linked, their states correlated beyond classical explanation. Some physicists suggest that such entanglement is not merely a feature of the universe, but the very foundation of space-time itself. The geometry of the cosmos, its distances and durations, may arise from networks of entanglement, like threads pulled taut to form a vast fabric. In this picture, motion is not a journey through a pre-existing grid, but the shifting of relationships in a web of invisible connections. The flow of time and the expansion of space are not ultimate realities, but emergent patterns of deeper quantum order. The simulation hypothesis ventures further into philosophy, yet it is rooted in the mathematics of information. If the universe is describable by equations, if its particles and forces can be reduced to bits of information evolving under rules, then it resembles a computation. Advocates of this idea argue that any sufficiently advanced civilization might simulate entire universes, complete with conscious beings, for research, exploration, or reasons beyond human grasp. In such a reality, motion would not be inherent to matter, but programmed into the code, galaxies moving because lines of instructions demand it, atoms vibrating because algorithms cycle them forward. Whether such speculation reveals truth or merely reflects human fascination with technology, it carries a profound question. If reality is simulated, does motion itself have meaning beyond the illusion? Yet even within these speculative visions, humility is demanded. Each theory, multiverse, cyclic eons, holographic shadows, emergent entanglement, simulated realities, is a bridge extending into mystery, supported by fragments of evidence, but never reaching certainty. They remind humanity that the cosmos cannot be easily confined to a single narrative. Motion may be infinite expansion, eternal cycles, emergent illusion, or something entirely beyond comprehension. The limits of observation and theory mark the edges of knowledge, but beyond those edges, imagination dares to wander. The speculative fates of the universe carry an emotional weight as well as intellectual intrigue. They force reflection on what it means to exist within such a cosmos. If there are countless universes, then motion here is but one story among an infinity of others. If the universe is cyclic, then every movement is part of an eternal rhythm without beginning or end. If reality is holographic, then motion itself is less than it seems, a surface shadow of deeper truth. And if all is simulation, then every journey from the orbit of planets to the beating of a human heart is both real and unreal. significant within its own frame, yet perhaps inconsequential in the architecture beyond. Speculation does not diminish the wonder of the cosmos. Instead, it enlarges it. For if even one of these theories holds a fragment of truth, then motion, the drift of galaxies, the rhythm of stars, the pulse of time itself, may be the expression of a reality deeper than physics alone can grasp. The universe may not simply move through space. It may be moving toward revelation in the present age. The pursuit of cosmic truth has become a vast orchestra of instruments, observatorius, and minds scattered across the earth. Each experiment is a note, each telescope a voice, all converging toward one symphony. To measure the hidden currents that govern the universe's endless motion, the dark energy spectroscopic instrument, mounted on a quiet mountain in Arizona, gazes into the night with robotic precision. Its task is monumental: to chart the positions and movements of millions of galaxies, not as isolated islands of stars, but as traces of the cosmic tide. In their recession, in their subtle drift, lies the fingerprint of dark energy itself, the unseen force stretching the universe ever wider. Each spectrum captured by DESI is a thread of light unraveling a mystery older than time, far beyond Earth's atmosphere. Europe's Euclid Space Telescope extends this effort into silence. With eyes free from atmospheric distortion, it maps the invisible scaffolding of dark matter by watching how galaxies bend and stretch the light behind them. In these distortions, known as weak lensing, lies a hidden cartography of mass and motion. If dark energy is the wind that drives the expansion, dark matter is the invisible ground upon which galaxies march. Together, they shape a cosmos where only a fraction of the story is told in visible light. On the deserts of Chile, the Vera C. Rubin Observatory prepares to record the night sky in unprecedented detail. Its legacy survey of space and time will capture billions of galaxies across 10 years, creating a time-lapse of the universe itself. Where past astronomers etched star charts by hand, now supercomputers will process floods of data so vast they defy human scale. From this deluge of images, subtle patterns will emerge: galaxies clustering, voids stretching, cosmic filaments weaving across the dark. The motion of the universe will not only be measured, but witnessed in living detail, as if the cosmos itself were breathing across the screen of human understanding. Between these luminous structures lie cosmic voids, immense caverns of near-nothingness stretching hundreds of millions of light-years across. Though they appear empty, their silence speaks volumes. By mapping their geometry and growth, scientists probe how dark energy sculpts the universe, not just in the crowded regions of galaxies, but in the vast stillness where almost nothing resides. The voids, paradoxically, may be the clearest mirrors of cosmic motion, revealing how expansion accelerates in the absence of matter's gravitational pull. Even the smallest of particles join this story. Neutrinos, nearly massless, born in nuclear furnaces and violent cosmic events, stream through the universe in uncountable numbers. Their motions, though faint, ripple into the architecture of galaxies. Cosmologists track their subtle influence, for in their restless drift lies a record of the earliest moments after the Big Bang. If dark matter is the skeleton of the universe, neutrinos are whispers carried on the cosmic wind, shaping structure with invisible hands. To interpret such complexity, humanity has built digital universes within machines. Supercomputers simulate billions of years of cosmic evolution, from the clustering of dark matter halos to the ignition of stars and the birth of galaxies. These simulations are not mere animations. They are laboratories where theories are tested against the unfolding tapestry of real observations. By comparing the virtual cosmos to the one painted across the night, scientists refine their understanding of the laws of motion that govern both atoms and galaxies. Yet even these monumental efforts are fragments of a greater whole. No single nation or observatory could attempt such a task alone. The search for cosmic truth has become a global endeavor, an intricate dance of collaboration across cultures, languages, and continents. In this sense, science itself is a form of motion, not of galaxies or particles, but of humanity striving together toward understanding. Just as matter and energy follow the laws of physics, so too does knowledge follow its own trajectory, propelled by the collective will to know. Still, an ultimate question lingers, hovering at the edge of every experiment. Can all these motions, from the trembling of quarks to the spiraling of galaxies, be traced back to a single principle? A unifying law that explains not just the existence of motion, but its necessity. Some search for it in the equations of quantum gravity, others in the geometry of higher dimensions, still others in the entanglement of invisible particles. But as of now, the cosmos resists full translation. The story of motion remains unfinished, written partly in light, partly in silence. And so the instruments continue to watch, the data continues to flow, and the universe continues its ceaseless drift into mystery. Humanity, in its small corner of the cosmos, presses onward, not to stop the motion, not to control it, but simply to understand why the universe moves at all. Beneath the vast dome of the Atacama sky, arrays of radio dishes turn their ears to whispers older than stars. The square-kilometer array, still in the making, promises to deepen this listening. With sensitivity unmatched in human history, it will trace hydrogen, the universe's most ancient element, across billions of years. In the faint glow of hydrogen's radio emission lies a record of how galaxies first formed, how filaments first grew, how motion itself cascaded from the simplicity of primordial gas into the complexity of cosmic webs. Where optical telescopes see the fireworks of galaxies, radio arrays uncover the hushed foundations beneath. Alongside them, neutrino detectors rest in silence, buried deep beneath mountains, under Antarctic ice, or within old mines. Vast tanks of water and scintillating liquids wait for a rare flash, a trace of the nearly invisible particles that stream endlessly from the sun, from exploding stars, and perhaps from the cataclysms that shook the infant cosmos. Ice cube, embedded within a cubic kilometer of Antarctic ice, transforms the planet itself into an observatory, capturing trails of light left when neutrinos collide with atomic nuclei. Each detection is a fragment of the cosmic symphony, a particle carrying the memory of its violent origin across distances incomprehensible to the human mind. To chart their motion is to eavesdrop on processes hidden from ordinary light. Black holes consuming matter, neutron stars colliding, the universe itself reshaping in silence. Gravitational wave observatories, to add their voices. With laser beams stretched across kilometers of vacuum tunnels, LIGO and Virgo measure ripples in space-time itself. These waves, faint as a shifting atom's width, emerge from titanic collisions, black holes merging, neutron stars spiraling together. In their detection, motion is no longer inferred from light, but inscribed directly in the trembling of the universe's fabric. Each ripple is a messenger, proof that motion is not confined to matter, but woven into the geometry of existence itself. Planned detectors like the spaceborne LISA promise to open this symphony even further, capturing the deeper, slower notes, supermassive black holes entwined in ancient dances at the hearts of galaxies. As instruments multiply, The challenge becomes not only collecting data, but comprehending it. Petabytes pour from telescopes, accelerators, satellites, and detectors, too vast for the human eye to pass unaided. Artificial intelligence has become a silent partner in this search. Machine learning algorithms sift through floods of cosmic information, discerning patterns no single mind could grasp. They identify subtle distortions, faint accelerations, improbable alignments, all signs of the invisible forces shaping motion. Where once astronomers gazed at photographic plates under dim red light, now entire machine intelligences help decode the vast ledger of the stars. In this sense, the pursuit of cosmic truth is no longer purely human. It is a collaboration between biological and artificial minds, united in wonder at a universe still beyond both at the same time. Particle accelerators such as CERN's Large Hadron Collider probe the smallest scales of reality. Bursts of energy recreate conditions not seen since fractions of a second after the Big Bang, offering glimpses into the forces that might underlie cosmic acceleration. Some theories suggest that dark energy is linked to the quantum vacuum, the restless field from which particles perpetually flicker into and out of existence. If true, then motion on the grandest scales of galaxies may find its roots in the tiniest fluctuations of quantum fields. In colliders and detectors, the extremes of scale meet the subatomic and the cosmic, the fleeting and the eternal. Humanity's instruments do more than measure. They extend awareness into realms the senses cannot touch. Each telescope, each detector, is a prosthetic organ of perception, transforming what is invisible into what can be known. The night sky that once appeared serene is now alive with motion, galaxies racing away, space-time trembling, particles streaming. Instruments allow humanity to glimpse the truth. Stillness is an illusion, and all that exists is caught in ceaseless drift. Yet the more the cosmos is measured, the more elusive its essence becomes. Each answer gives rise to deeper enigmas. Why should motion accelerate? Why should matter curve space-time, or vacuum energy drive expansion? What principle unites the galaxy's flight with the neutrino's whisper? The present scientific efforts are monumental, but they circle around a horizon of mystery, a boundary where data ends and interpretation begins. The pursuit of cosmic truth is not merely about collecting more light, more signals, more numbers. It is about reaching for a unifying story, one law, one equation, one idea that might explain why there is motion at all. In observatories on mountaintops, in detectors carved into the earth, in satellites gliding through space, the search continues. Humanity moves outward, even as the universe moves away. Both journeys, human and cosmic, entwine in a single mystery, the quest to understand the restless unfolding of a universe where nothing, not even silence, remains still, from the smallest stirrings within an atom to the silent drift of galaxies beyond sight. Motion is the pulse of existence, and in this restless cosmos, human beings are no exception. Each life unfolds in rhythms of motion, the beating of a heart, the firing of neurons, the slow erosion of bone and stone alike. Thoughts themselves are migrations, darting across synapses, forming constellations in the quiet of the mind. Humanity is born in motion, grows in motion, and departs in motion, carried onward by the same law that steers comets and stars. The symmetry is haunting. Just as galaxies scatter in an endless flight, so too do lives stretch forward, never truly pausing, always pressed toward tomorrow. The river of time carries everything, whether stone or star or fragile consciousness, and in this shared momentum lies a reflection of destiny, fleeting, fragile, yet inseparable from something vaster. Einstein once mused that the separation between past, present, and future is only an illusion, however persistent. To him, motion through time was as fundamental as motion through space, each inseparable from the geometry of reality itself. Stephen Hawking, gazing into black holes and beyond, suggested that perhaps there is no edge, no final wall to strike, but rather an unbroken continuum, a universe without boundary, where beginnings and endings dissolve into cycles of transformation. And Carl Sagan reminded humanity that it is not merely drifting observers, but participants star stuff, contemplating the currents of which it is made. These reflections converge upon a singular paradox. If everything moves, if everything is carried along, can there be such a thing as arrival? Or is existence itself condemned to an endless unfolding, where no final point of stillness waits at the end of the journey? For some, this is unsettling, a reminder of impermanence. For others, it is liberating, dissolving the need for ultimate answers, offering instead the embrace of the voyage itself. The universe may never grant stillness, but it grants continuity, a thread woven from quarks to galaxies, from a human breath to the cosmic wind. Perhaps meaning does not lie in destinations, but in the motion itself, in the act of becoming, transforming, and carrying forward. The galaxies that drift apart will never return, yet in their separation they write a story of expansion. The stars that burn out surrender their atoms to new suns and new worlds. The lives that flicker for a brief span ripple outward in memory, in action, in consequence. So the closing reflection becomes clear. In a universe where nothing rests, perhaps rest is not the goal. Perhaps the true wonder lies in the ceaseless dance, in the fact that anything exists to move at all. Arrival may be an illusion, but motion, eternal, unbroken, immeasurable, is real. And in that endless tide, human beings find not just insignificance, but belonging. For they, too, are part of the journey, threads in the current, passengers in the great river with no mouth and no end. Here, motion itself has meaning. The journey is the destination, and the story of the cosmos continues, flowing onward into forever. The awareness of ceaseless motion has always haunted human imagination. Ancient myths spoke of rivers encircling the world, of celestial wheels turning eternally above the earth, of gods whose journeys mirrored the cycles of the sky. Even before science, there was recognition that nothing ever stood still. The sun rose and fell, the seasons shifted, children grew into elders. To live was to move, and to move was to change. Science stripped away the metaphors, but revealed something even more profound. Motion was not a superficial feature of reality, but its very framework. Without it, time itself would have no meaning. For time is measured not by clocks, but by change. A pendulum swinging, a planet circling, a heart beating. Remove motion, and even eternity collapses into silence. And so, the human struggle to find meaning is inseparable from this awareness. Every achievement is motion extended into the future, the words of poets, the discoveries of scientists, the architecture of civilizations. Even memory is a kind of motion, a tracing backward across the stream, revisiting moments that no longer exist yet continue to ripple. Humanity, in its search for permanence, creates art and science, stories and structures. Yet permanence is never found. Only motion endures. This realization can feel like a wound, for it denies the longing for arrival, for stillness at the end of the road. Yet it also offers a deeper consolation. If nothing stands still, then nothing is ever lost entirely. Every star that dies seeds the birth of another. Every atom once locked in ancient oceans or mountains now flows through living veins. The universe recycles its own movement, reweaving patterns endlessly, though never the same twice. The philosophers sensed this long before the astronomers confirmed it. Heraclitus, in ancient Greece, declared that no one steps into the same river twice. Centuries later, this truth echoes in the galaxies themselves, rushing apart in currents that will never return. But perhaps the deeper message is not despair, but awe. The river flows, and because it flows, life exists. The cosmic perspective deepens this reflection. The galaxies moving away at unimaginable speeds are not abandoning meaning, but expanding the stage upon which meaning can emerge. Without expansion, there would be no stars, no chemistry, no worlds. The ceaseless dispersal of matter and energy gave rise to the conditions that allowed human consciousness to briefly awaken. The universe moves endlessly forward, and in that forward motion, thought itself arose to ask why. In this sense, motion is not only the context of human existence, but its enabler. The journey is not merely symbolic. It is the literal reason life and thought exist. Without the flow of particles, the burning of stars, the orbit of worlds, there would be no heartbeat, no consciousness, no question of meaning at all. So perhaps the ultimate reflection is this: to move is to be alive, and to move is to belong. Humanity shares its restlessness with the galaxies, its transience with the stars, its curiosity with the very fabric of space-time. The question of arrival dissolves, for arrival is not the design of a universe that flows forever. Instead, meaning is found in participation, in being part of the grand migration, even for a brief span. The closing image is haunting yet beautiful, a cosmos without stillness, yet not without grace. A universe where the destination may never appear, but where the act of motion itself is enough. For in every drifting galaxy, in every fleeting life, the universe finds its voice, whispering that the journey is all there is, and all that is needed. From the smallest stirrings within an atom to the silent drift of galaxies beyond the range of sight, motion defines the universe with a certainty deeper than law. It is not imposed from outside, but woven into the fabric of space-time itself. To imagine a still cosmos is to imagine one without breath, without time, without story. It would be the silence before creation and the silence after its end. This knowledge presses upon the human mind with a paradoxical weight. On one hand, it reveals a universe indifferent to rest, forever caught in tides it neither begins nor ends. On the other, it whispers of kinship, for within the fragile human frame beats the same truth. The heart is a pump of perpetual motion, each contraction a wave against the abyss of stillness. Neurons spark like distant lightning storms, carrying thought along invisible highways. Breath after breath, step after step, the body itself is a galaxy of ceaseless migrations. This likeness between cosmos and creature did not escape the thinkers who shaped the modern imagination. Albert Einstein, when contemplating the relativity of motion, confessed to a deep sense of awe. To him, time and space were not static arenas, but participants in a cosmic dance, bending and flowing in response to mass and energy. Stephen Hawking, gazing into the heart of black holes, framed existence as a tension between entropy and order, motion into collapse, countered by motion into expansion. Carl Sagan spoke in the language of poetry, reminding us that we are star stuff, not merely because of the matter we contain, but because we, too, are currents within the greater stream. If motion is endless, then the longing for arrival becomes an eternal question. Every human journey begins with hope for a destination, a summit, a conclusion, a final rest. Yet in the cosmic sense, there may be no such arrival. Galaxies will not settle into stillness. They will drift farther until the distances between them grow so vast that light itself cannot bridge the gap. Stars will burn out, matter will decay, and even the most enduring structures may dissolve into the cold stretch of time. To ask where it all is going may lead to the haunting answer. It is going, only going, never to arrive. But within this haunting lies a profound real. If the universe itself knows no final resting place, perhaps meaning lies not in reaching an end, but in moving at all. The wave has purpose, not because it lands upon a shore, but because it rises, crests, and falls, passing its energy into the sea around it. Human life mirrors this same pattern. The value is not in a final stillness, but in the unfolding, in the laughter shared, the knowledge gained, the compassion extended. These are not arrivals, but moments in motion, brief and luminous. In every culture, traces of this truth emerge. The Buddhist wheel of becoming, forever turning. The Stoic vision of a cosmos governed by eternal cycles. The scientific recognition that energy is never lost, only transformed. The metaphors differ, but the message converges. Permanence is illusion, yet participation in the flow is real. This realization deepens into a quiet kind of hope, for if motion never ends, then nothing is entirely erased. The light of extinct stars still races across the void, carrying the story of their existence to distant eyes. The words of long-dead poets still echo in the minds of those who read them. Even human presence on this planet is motion extended into the biosphere, woven into soil, air, and ocean. Every heartbeat, every step, every thought is a ripple that enters the larger stream, and though it may fade, it is never wholly gone. The haunting question remains: can there be arrival? The answer, perhaps, is that arrival exists only in moments, never in finality. A mother holding her child. A scientist glimpsing the pattern hidden within data. A voyager seeing a new world crest the horizon. These are temporary arrivals, sparks of stillness in a sea of becoming. They cannot last, but their impermanence does not lessen their weight. On the contrary, it makes them precious. Thus the human reflection mirrors the cosmic. The galaxies stream outward, the stars churn their nuclear fires, the planets spin their endless circuits. Humanity, too, moves forward, not toward a final end, but through an unfolding. The destination is not stillness, but participation in a journey so vast that it cannot be measured in lifetimes or epochs. The universe does not promise rest, but it offers belonging. And in that belonging lies meaning. The chapter closes in silence, yet not the silence of absence. Rather, it is the silence of watching the Milky Way drift across the night, knowing that its spiral arms carry billions of worlds, each in motion, each telling a fragment of the same story. Motion is not an accident of the universe, nor an obstacle to overcome. It is the very essence of being. To exist is to move, and to move is to share in the eternal pilgrimage of the cosmos. And perhaps that is enough. The camera drifts outward, away from Earth's thin atmosphere, past the pale shimmer of the moon, beyond the golden trail of planets orbiting a modest star. Further still, it slips across spiral arms, past clusters of galaxies, into the immeasurable dark. Everywhere motion continues, stars migrating, voids expanding, time itself unfolding like a river without banks. In this boundless journey, humanity is not an observer standing apart. It is a current within the flow, fleeting yet inseparable, a spark borne along the eternal tide.